Hey guys, welcome to my YouTube channel. My name is Wireshark, and on this channel I document my journey into cybersecurity. This is the second video in the Wireshark tutorial video series, and today we will learn display filter expressions. I'll put a link to this site in the video description. As usual, these files are password protected, so download them, extract them. The password is infected. We will start with this emotet file. Before I start, I want to talk about the importance of display filters, why we need display filters, and how display filters can help you narrow down your search. So if you're working in a SOC, you're collecting tons of data, and you're oftentimes looking for something very small. It's like looking for a needle in a haystack, and using display filters, you can narrow down your search and find exactly what you're looking for. So that being said, we'll open the first file. Okay, so this is what the first file in the exercise looks like, with no filters applied, nothing, just the pcap file. This is your display filter bar. This is where you will be entering your expressions. So Wireshark tries to color code the expressions, so if an expression is not accepted and if it's wrong, if it doesn't make sense, your bar turns red. So as you can see, as I'm typing this request, as I'm typing this expression, the bar is red because right now it doesn't make sense. Now turn green, and request. Yeah, so if you type something that makes sense or an expression that is valid, and if it works, it'll turn green. And sometimes you'll see the bar turn yellow, which means it's accepted and it may work, but sometimes it may not work as intended. So that's what the bar is trying to tell you. It doesn't matter. Sometimes when it turns yellow, it still works fine for me. HTTP.request is a filter that filters out HTTP traffic. SSL handshake is for HTTPS traffic. This OR operator is a conditional operator. So there are different kinds. There's EQ, which means equals. Double equals also means the same thing. Or and for and you use A and B, or you can use double ampersand. For OR you type or use double pipe. So very first file, we will try to look for HTTP traffic, web traffic type group 1. Hit that. So you're seeing web traffic, and it's mostly web traffic. You see, this is all web traffic, but we're also seeing something called SSDP on port 1900. This is UDP, if I'm not wrong. Yeah, it's UDP. It's normal, it's nothing malicious. This protocol is used for plug and play devices. So if you're looking for web traffic, you may want to remove this from your results. It's nothing malicious, nothing to inspect. So we can remove this by using another conditional statement. You put this in a bracket, type and SSDP, not SSDP. So this will filter out all SSDP traffic from our results. So now you see only HTTP and HTTPS traffic. So that's our very first web traffic filter expression. So now we move on to the next. Sometimes, here's a quick tip. Sometimes, if you want to filter out a value, you will do that by, best way to do that, you can type IP.address address not equals something 192 or 81. This will work, but it's always best practice to put this in a bracket. IP.address equals, type in the IP. So I'll type in 37 and add a not an exclamation outside, so this will filter out everything, so that this works much better in my experience. And this is what even Brad tells us in his blog posts. Just a dip, do whatever you want. Okay, so now we look at web-based infection traffic. We just saw our very first filter expression, and now we'll add on to that. Let me type that back. Okay, so we're back to our web traffic again. This is pretty much what the first file teaches you to set up web traffic expressions. So now we'll open our second file. In some cases, yeah, looking at the web traffic may not give you the complete picture, because some malware may use other protocols or other means of communication. Like, let's say, for example, it uses DNS. So just to make sure our malware is not communicating using DNS, we'll also try to look up some DNS queries. So we use the same filter expression again. Type equals 1 for DNS and not equals to SSTP. Okay, so this gives us some DNS queries as well. Okay, why do we do this? Because sometimes, like I said, malware can be trying to communicate with some C2 servers without HTTP or HTTPS. So looking at DNS may give you a better understanding. Like you see here, there was a query, DNS query sent to this IP, this domain, and again there was an HTTP request, GET request, downloading a executable mko.exe. That's an executable. We don't know what that is, but that's an executable downloaded over HTTP. Potentially malware, maybe, I don't know. Now let's look at TCP flags equals 0.000. Okay, do this to identify SYN requests. As you can see, there was a DNS query sent to this domain, franixtites.net, and that returned an IP address, and we send a TCP, the infected host sends a TCP SYN packet to this IP address, 185.163.45.48. We use that in the filter expression. We write TCP flags equals this number 0x002. That's the SYN packet, and so we get a better understanding of what's going on. So this is the second file of the exercise. This is pretty much what it does. We'll explore more in the other file, which is file 3. So you go to the site, you download this file, ftp malware pcaps.zip, type in the same http request for SSH and doesn't equal SSTP. We use the same filter expression. This is all we're presented with. As you can see, using the DNS protocol on the very first row, you can see there's been an HTTP. There's a request to an HTTP domain. FTP. That's HTTP. I meant FTP. FTP.anonymous.com. So now we will remove. So this gives us a clue, yeah. So we'll remove the expression completely. Search for FTP. You see, this is everything that's associated with FTP protocol, and the info gives us a very clear idea of what's going on. For those of you all that don't know, FTP is not encrypted. FTPS is, but FTP is not. So you can see what's going on in the background. So a user try to log into this FTP server using this username, this password, and he checks the size, retrieves it. Okay, he downloads this file, some exe malware, then 432, another exe, could be malware, another exe, ip.exe. It's very important to look at the time, because when you're a SOC analyst doing your analysis, you're trying to build a timeline of things that happened, and it's important to know what happened when, and that could sometimes lead you in the right direction. So now we know this host has been downloading malware, exes, executables. We don't know if it's malware, some executable. So these are executables that were downloaded. It was very simple. We used our initial filter expression. We got to know something fishy was going on with FTP. So now we use FTP and filter out only FTP logs, and we're getting a better idea of what's going on. And as you can see, if we keep scrolling down further, the host is trying to upload something. Uploads, not trying. He or she successfully uploads a file. This is the name of the file, and then they log out. That's pretty much what this exercise teaches you. So now we go on to the fourth pcap file. So again, pp. Okay. So you type in your web traffic filter expression. Why do I keep saying web traffic filter expression? Yeah, okay, web traffic filter expression. You see there's a lot of DNS requests to an SMTP server, SMTP mail.me, SMTP mail.yahoo. So maybe we should look at SMTP. And for that reason, I look for SMTP logs to write SMTP. Sometimes when you see star TTLS, not sometimes, always, when you see star TTLS, it's SMTP that's encrypted. So there's no point examining that because it's encrypted. You won't see anything. So for that, newer versions of SpamBot usually have encrypted SMTP. So there's no point trying to examine it. So for this reason, we will type contains from. So what this basically means is SMTP frame, any frame that contains the word from and colon. This is case sensitive, so make sure the F is capital. What this does is filters out frames that have the word from colon. This should give us unencrypted SMTP, 7 packets. So right click on any one of them, click follow TCP stream, and you should be presented with some part of the packet. Since this is not encrypted, you can see what's going on. If this was encrypted SMTP, you wouldn't be seeing all this. And that's pretty much it. Okay, so now this brings us to the end of this video. I want to show you all something very important here. As you saw throughout the video, we were typing in this expression. We did this, what, 5, 6 times? Yeah, I don't remember. And sometimes when you're looking for something, for example, we did web traffic, 3 or 4 times. And it gets, sometimes you're typing the same thing again and again. So it's, in Wireshark, you can create a filter. Label for the filter is web traffic. Filter is HTTP request or SSL or handshake dot type equals 1 or DNS. No, actually this is enough. This is enough. And doesn't equal SSTP. Okay, this is a good expression. Comment web traffic basic. Okay, so that should create a filter button right here. And if you're too lazy to type, just click on this. That should do the job. You can create your own filters, and it's very helpful when you're doing analysis. We'll create multiple buttons. By the end of this video series, we should have more buttons here. And that's pretty much it. I'll see you guys in the next video. Peace.